So here we have our experimental setup. We have this phone contacting this table with a combined mass of the phone and the water of 500 grams. We then have this cable connected to the phone, running through this pulley and down into this cup, which will create a mass by filling it with water. Now, as that mass gets heavier and heavier, this will create more and more tension force. When this tension force exceeds the force of friction between the phone and the table, this phone will begin to slide. And that's how we're going to calculate our coefficient of static friction, which is the aim of this experiment. Now, if we take a look at the friction force formula, we can see that the force of friction is directly proportional to the normal force applied across the two surfaces, with a proportionality constant of mu. Now, in this formula, mu is the same as the coefficient of static friction. And since we know that the normal force applied across the two subjects is 500 grams acted upon by gravity, and we're about to measure the force of friction, i.e. the force and the tension force needed to make the phone move, we can easily calculate mu. So with this experiment, we're taking some pretty major assumptions for granted. Firstly, we're assuming that this cable is pulling directly along the surface of the table. In reality, there might be a small angle, but we're going to consider it negligible. Secondly, we're assuming that this pulley is completely frictionless, so that when we measure the friction force, we're only measuring the one between the phone and the table. Thirdly, we're assuming that this cable's mass is negligible. Okay, so here we go. As I fill this, it's creating a larger and larger and larger tension force in the cable. When there's enough mass in this cup to create a force larger than the friction force between the cup and the table, between the phone and the table, the phone will begin to move. And there we have it. And that force is the equivalent of 420 grams acted upon by gravity.
To solve for mu, we can use our equilibrium equations to solve for mu. Now, our first step is actually to solve for t. So we will do so by solving for f of y. Sum of forces y at cup 1 is equal to 0, and that is equal to t minus m1g. So t is equal to m1g. And then we need to solve for our normal force, which we can do again with sum of forces y, but this time at cup 2 equals 0, which is n minus m4g, with m4 being m2 plus m3, which is the mass of the phone and of the water. Our last step is to solve for the friction force, and we can do so by solving for f of x at cup 2. Now this is equal to 0, which is f of f minus t, which we know is m1g. So f of f is m1g. We also know, due to our formula, that f of f is equal to mu n, which we know to be mu m4g in this case. Therefore, mu m4g is equal to m1g. And we can simplify to give us m1 on m2, m4, as the g's cancel out, which we can then substitute our values in to find that the coefficient of static friction between the phone and the table is equal to 0.84.